with these questions, I think it's always worth reading them through a couple of times and checking that you've got all of your information in one place. So the diagram shows a regular playground, width x and length 3x, so that's that. The playground is extended by adding 10 metres to its width and 20 metres to its length to form a larger rectangular playground. I would now draw that. Okay, so you're going to have to excuse my poor drawing. I can't draw lines on here, so it's the program I'm using. But if I've extended the length of the width by 10 and the length by 20, the width here is going to, the width of the extended playground is going to be x plus 10, and the length of the extended playground is going to be 3x plus 20. So 3x plus 20. If I then read the next bit, it says the area of the larger rectangular playground is double the area of the original playground. So I have to consider what that means. Well, the area of the larger playground is length times width, so 3x plus 20 times x plus 10. The area of the smaller playground is 3x times x, or x times 3x, and this one is twice this one. So now I just need to do some algebra and expand and rearrange. So this is the way I've shown it. First of all, I've expanded the left-hand side using first, outside, inside, last. So 3x times x is 3x squared, 3x times 10 is 30x, 20 times x is 20x, 20 times 10 is 200, and that equals 2 times, where x times 3x is 3x squared. So I can combine, on the left hand side I can combine 20 and 30x is 50x, on the right hand side that makes 6x squared, and then the last step is I just subtract 3x squared, 50x and 200 from both sides, and I've got 3x squared minus 50x plus 200 equals 0, which is what was required up here. In fact, that was a good job I checked, because actually I'd made a mistake. When I subtract 200 I should have minus 200 here, so it was a good job I checked back with the original question. So for part B it says we'll calculate the area of the original playground. Well, I can see from my diagram that the area is going to be 3x multiplied by x, so 3x squared. The question now is, how can I figure out the value of x? So I can find x by solving the equation I worked out in part A. And by the way, if you weren't able to complete part A, that's not a problem, it was given in the question, so you could still work on part B. So we're solving 3x squared minus 50x minus 200 equals 0. There's a few different ways of doing it. If it's a quadratic, clearly you could use completing the square, you could use the formula. I think this is going to factorise, so I'm going to factorise it, and that's what I'm doing over here. I know that to make 3x squared I need 3x and x. I now need two numbers that multiply to make negative 200, and I think if I take 10, positive 10, and negative 20, let's see if that works. Well, I've got 3x times negative 20, which is minus 60x. 10 times x is plus 10x, so minus 60 plus 10x is minus 50x. So I think this works. So I can now continue. So I've got 3x plus 10 times x minus 20 equals 0. Two things multiplied together equal 0. One of them must be 0. So either 3x plus 10 equals 0, so x is minus 10 over 3, or the other bracket, x minus 20 equals 0, so x equals 20. Clearly we now need to think about what x means. X cannot be negative, so we can reject this answer, because x is the length, it's a length of it's a length, so it must be bigger than 0. So we can write reject this answer. So we've got the answer, x equals 20. It's now very simple to calculate the area, because we know that the area is 3x squared. And I've got the area is 3x squared, 3 times 20 squared, which is 3 times 400 is 1200, and the units metres squared. So my answer is 1200 metres squared.